now that we've talked about what happens on a molecular scale, let's talk about what's happening on a larger scale. And this is something called Ohm's law. And it says resistance. Remember drag resistance and fluid resistance. They were the ratio of a force or force-like quantity to a rate. So for electrical resistance, the force or force-like quantity that drives flow is potential difference, delta V. And the rate is the current flow over I. This is called Ohm's law. And what Ohm showed is that for certain materials, especially conductors, over certain regions of voltage and current, you get something like this. If I plot voltage versus current, I'm going to get a straight line, which means that the voltage and the current, they're proportional. And so the slope, the resistance, is constant. So for ohmic conditions, the resistance doesn't change. If I double the voltage, I double the current. And the ratio always stays the same. Now this is going to break down at some point. If you throw so much current through that you break down the system, you change the material by melting it or something, then it becomes what's called non-ohmic. But this is Ohm's law. Let's see if we can use it. Let's see, I've got a circuit. Got a resistor. The resistor is what slows down the flow. And let's say I've got a voltage of 24 volts, potential difference. And let's say I'm running a resistance. By the way, now when you're talking about resistance, the resistance is in ohms. Let's put that right there. Ohms. That's the resistance. Okay? Voltage over current. So volts per amp gives you ohms. The symbol is this. So let's say we've got a current of 6 amps. I want to know what's the resistance. The resistance is the voltage, potential difference, divided by the current, which is going to be 24 volts, divided by 6 amps, which is going to be 4 ohms. So that means an ohm is a volt per amp, which is a joule per coulomb over coulomb per second, which is a joule second per coulomb squared, which is pretty screwy, which is why I say you can use ohms. If you're given the voltage and the resistance, you can solve for the current. If you're given the resistance and the current, you can solve for the voltage using Ohm's law. So it's a very handy piece. Now we should talk about resistors in series and in parallel.